Welcome to Mr. Georgiadis's lesson plan on logarithmic equations, day one. As I do now, we're going to start with simple log equations that require one or two steps, just how we have been doing the last few days. For the first one, we have a log base x. Uh, 81 equals to 4. As we remember, converting a log to an exponential is as simple as starting with the base, which is x, raising it to the fourth power equals to 81. When we have a variable to the fourth power, to eliminate that 4, we would have to raise both sides of the equation to the reciprocal of the exponent, the 4. And as we know, 4 is really 4 over 1, so we're raising it to the 1 over 4th power to both sides of the equation. This will eliminate the exponents, and then you will be left with x equals 3, which is 81 to the 1/4 power. However, we've noticed that the exponent is an even number, therefore we should have two answers, positive 3 or negative 3. And by a simple substitution into the original equation, can verify that that would work for a positive and a negative 3. However, the base of a log can never be a negative, so we would have to eliminate the negative exponent, which will leave us only with one solution, x equals positive 3. Now let's go to problem number 2, which is a very similar problem. However, the variable is now not on the base. It's next to the log, but we're dealing with it the same way. We have a log equation with one log, and all we have to do is change to an exponential equation, convert base is 5, exponent is negative 1, and that would be equal to the x. And that you can put in the calculator, or if you remember, 5 to the negative 1 is the same thing as 1 over 5, which is the answer to the x. Further down, we'll find two more problems that involve log or converting logs to exponentials. Number 3 has a variable in the exponent, and therefore this would be an exponential equation, and we would have to obviously convert it to a logarithmic equation. And the method is very similar. I usually start with the log of the same base as the exponential, which was the base was 5 of 7 equals to 2x plus 1. Solving this little simple equation requires to isolate the variable. Therefore, we would subtract 1 from both sides. This will eliminate this 1, and you would continue by rewriting the equation as log base 5 of 7 minus 1 is equal to 2x, and then we would have to divide both sides with 2, which eliminates the 2, and then it's just a simple problem involving you substituting all these numbers into a calculator and giving you the correct answer, which is log base 5 of 7 minus 1 all over 2. Continuing to the last problem for the do now, is a log equation. This time the variable is isolated already. As you notice, it's all by itself, so there's no conversion required, just exchange in base formula, which is a log of base 2 of 239 divided by log base 6. I mean log 6 divided by log 6. And that would give you the answer to the x. Now let's go to today's lesson where it's a log equation where a simple conversion will not be suffice. We would have to eliminate this 2 in the front here before we do any change of base or change to exponential. So a simple way of doing this would be dividing 2 to both sides, eliminates the 2, and we would have a log of 128 base x equals 7. And as we saw before, we would change it to an exponential once again, which would be x to the 7th power equals 128, which was very similar to the problem that we did before. This time we would raise both sides to the variable to the exponent of 1/7. That will eliminate these exponents, and you would have left with the answer x equals the 1/7 power of 128, which is 7. Or was it 6? No, I believe it's 7. Use your calculator to verify. The next problem is very similar. As we can see, there's a little 3 in there in the front. The coefficient is 3. We would have to eliminate that 3. So basically, we are isolating the log from everything that would be around it, so that we'll be able to convert it on our next step to an exponential. Equals to 2. Now converting requires a base, and this log has no base. But if we recall, when the log does not have a base, it is automatically by base 10. So now, after we know that little fact, we can convert into an exponential. 10 to the 2nd power equals to x plus 4. This would be equal to 100 equals to x plus 4. And we would have to subtract 4 to both sides to get our final answer of x equals 96. That concludes our preliminary problems, our do now. Very important to remember that when we're dealing with log equations, as simple or as hard as they might be, the most important thing is to be able to isolate the log, then convert into an exponential, and then solve a simple log equation. Here are 2 more examples that require us to do the same thing. Divide by 2 on both sides, we'll eliminate the 2, and therefore we would isolate the log. In this case, the log is an ln. But let's remind everybody, all a ln is a log with base e, the natural number e, to the a log base e of x. That's all that ln is. So if it makes your life easier, might as well convert that ln to log base e of 3x equals 9. Now it's easier to see how we can convert into an exponential. We always start with the natural base here, which is e, and that would be our base for the exponential. E to the 9th power is equal to 3x. And to solve for x, we would have to divide 3 to both sides, and that will eliminate this. So x will end up being e to the 9th divided by 3. And now you can plug into the top to get your answer. On the next problem, once again we have a ln, a natural logarithm, and I always would like to see what that really means. It's really a log base e of 2x plus 4 in a parentheses equals x squared. And there we're going to convert into an exponential, starting with the base e of x squared equals to 2x plus 4. However, this is a much more difficult problem, so we will deal with it at another time, or I will assign it as a bonus, and we can cover this in the classroom. Following the next problem, we're having a log base 2 of 2x minus 3 equals 3. I will quickly uh, jump to the exponential form, which is base 2 of 3 equals 2x minus 3. The 2 to the third power is simply as 8 equals to 2x minus 3. And we're solving a simple equation right now, adding 3 to both sides and getting 11 equals 2x, and then dividing by 2 to both sides, which give us the final answer of 5.5. Let's not forget, whenever we get an answer to a log problem, we should always try to substitute that answer back into the original problem, just to understand that not all solutions will work. If there is a solution that results in the log having a negative number behind the log, or a negative number as the base, then we would have to eliminate that answer and reject it and leave the second answer or no answer at all to the problem. Going to the next problem, I see that the ln is not isolated. I would need to isolate this ln of x, so that means I would have to get rid of that 7 and that coefficient of 2. Simple idea, would subtract 7 to both sides. That would eliminate the 7. We will have 2 ln of x equals to negative 1. Divide both sides with 2, and you would have an ln of x equals negative 0.5, which our simple conversion to a log is base e of x equals negative 0.5, and now a conversion to an exponential with base e would help us here. An e to the negative 0.5 is equal to x, and all we have to do is put this into the calculator, and it will give us a decimal, and we would follow instructions of the problem, either to round that decimal to the nearest tenth, hundred, thousandths, or whatever the instructions might say. At this point, we have the summary of the first lesson of logarithmic equations, which describes what we need to do to solve simple logarithmic equations. First, we would have to isolate the log using simple algebra, either by adding or subtracting or multiplying, dividing both sides. Then we would have to convert to an exponential and solve for x after that using simple algebra equations. And always remember to check your answer for any extraneous solutions or no solutions. This concludes our lesson for logs. Remember, isolate the log, convert to exponential, solve for x, and check your answer always. Thank you and have a good day.